Hi again. This is the second part of the lecture. So let me just recap on what we have covered in the earlier slides. So basically we stopped at the problem-based estimation where we look into the 3-point or expected value where we use this formula to calculate the weighted average of the optimistic, most likely and pessimistic estimates. So in the example, we have tried to calculate the three-dimensional geometric analysis where we calculate the estimation and we get the value as 6,800 line of code. So from there, we use historical data to calculate further values such as cost per line of code or estimated project cost or estimated effort. So let's say from the historical data, we have the average productivity for systems, which is 620 line of code per month, and the burden labor rate is 8,000 per month. So from here, we can calculate the cost per line of code is approximately $13, which is 8,000, and we divide it by the average line of code per month. The second one is that we calculate the estimated project cost, which is the estimated line of code will multiply by the cost per line of code. So we know that the cost per line of code is 13 ringgit, $13. So we multiply it by 33,200, okay, from the estimated line of code, okay, and we get 431,000. And finally, we can also calculate the estimated effort, which is estimated line of code divided by average productivity per month. So we get 33,200 divided by 620 line of code per month. So we get the estimated effort is 54% months. Okay. But what are the problems with lines of codes? Okay, the first one is lack of universally accepted definition for what is exactly the line of code. The second one is it is language dependence. That means it depends on what kind of programming language that you use. So different programming language has different ways to calculate the line of code. It is also difficult to estimate the number of lines of code that will be needed to develop a system from the information that is available at the early stage of the software development. And finally, the lines of code emphasizes on coding, which is on the later stages of the software development, which is in the implementation. But when we do this estimation of line of code, we actually have not even started the real implementation yet. So that is mainly the major problems with lines of code. Now we go to the second technique, which is using the function points. So before we go further, we need to know a bit about what are function points. So function point measures software size by quantifying the functionality provided to the user based solely on logical design and functional specification. That means without waiting until the code is written, you use the information and calculate and measure the size. It's a method of quantifying the size and complexity of a software system in terms of the functions rather than looking at the code. So how do function points overcome line of code problems? The first one is it's independent of the implementation language, the development methodology, the technology, or the capability of the project team used to develop the application. And it can be estimated as early as in the analysis and design, since we don't have to wait until the implementation. Non-technical users could also have a better understanding of what function points are actually measuring because it's not as complicated as line of code. So what are the uses of function points? So we can use it to measure productivity, we can use it to estimate development and support, in terms of cost benefit analysis, staffing estimation. We can also use function points to monitor outsourcing agreements. Let's say some parts of the system we outsource it to third party or to another company to develop it. So we can use function points to monitor their progress. Drive information system related business decisions and also to normalize other measures. So the objectives of function point measurement are, the first one is to measure functionality that the user requests and receives. Measure the software development and maintenance independently of technology used for implementation. And it is simple enough to minimize the overhead of the measurement process. That means you don't need too many people or too many resources in order for you to calculate the measurement. And finally, a consistent measure among various projects and organization. That means if you have many projects, even because it is not dependent on the programming or implementation, so it can be used to various projects. So let's look into how we can calculate the function point. So I've simplified the steps. The first one is to determine the unadjusted function point count. Then we have to determine the value adjustment factor. And finally, we have to calculate the adjusted function point count. The first one, the unadjusted function point count reflects the specific countable functionality provided to the user by the project or application. So the unadjusted function point calculation is broken into 5 categories. So we have to know the internal logical files, external interface files, external inputs, external outputs, and external inquiries. The second one is to determine the value adjustment factor. So the value adjustment factor indicates the general functionality provided to the user of the application. So it is comprised of 14 general system characteristics. So we're going to look at the characteristic in the later slide. And each characteristic has associated description and help to determine the degree of influence of the characteristics. So for the degrees of influence range on a scale of 0 to 5, from no influence to strong influence. So these are the 14 factors that determine the value adjustment factors. So it depends on the data communications, distributed data processing, performance, configuration, the transaction rate, online data entry, until the facilitate change. So for each of these factor characteristics, we have to rate the degree of influence from 0 to 5. Okay, 0 indicates no influence and 5 indicates strong influence. So in order to calculate the value adjustment factor, we have to calculate all the and total up the degree of influence of all the 14 characteristics just now. So for example, let's say the value adjustment factor is calculated that if there are 3 degrees of influence for each of the 14 characteristics, so we multiply 14 by 3 and we get 42, and we multiply it by 0.01 and we add it with 0.65. So the value of value adjustment factor is 1.07. So the final step is to calculate the adjusted function point count. So the complete formula for function point is the count total multiplied by, so this is the value adjustment factor that we have calculated in the previous step. So let's look into an exercise. So the first one, we determine the unadjusted function point. So from the 5 perspective of these external inputs, output, inquiries, internal logical files, and external interface files, we have to first calculate and count how many inputs we have, how many outputs. Let's say in this example, we have 3 inputs, 3 output, 2 output, 2 inquiries, 1 logical file, and 4 external interface files. Okay, so this is the first step. Okay, the second step is to determine the value adjustment factor. So let's just assume that the value adjustment factor for this example is 46 because we need to have all those value for the 14 characteristics. Okay, and then the final step is to calculate the adjusted function point count. Now let's assume that the weighting factor is simple for all these 5 information domain value. So what we have to do is to come out with this adjusted function point for each of these information domain value. What we have to do is to multiply the count with the weighting factor. So in this case, we just assume that all of them are simple. Okay, so let's say the first one, 3 multiply by 3, so we get 9. 2 multiply by 4, we get 8. 2 multiply by 3, we get 6. 1 multiplied by 7, we get 7. 4 multiplied by 5, we get 20. So in order for us to get the total adjusted function point count, so we calculate all these values here, and in the end we get 50. So the total formula for function point is count total, which is 50 value. We multiply by the total adjustment factor. Okay, so we get around approximately 56. Okay, so that is the final value that we are trying to estimate. So as an example, I provided similar information for you to find out whether you understand how to calculate or not. So in this example, we assume that the VAF value is 52. Now calculate the function point using the same steps. So after you have calculated the value, I want you to try out to calculate what is the total estimated project cost and what is the estimated effort for this example. So now we're going to look at the process-based estimation. So the process-based estimation is slightly different than the problem-based estimation, where it is obtained from the process framework like your process model or the software development methodology. From there, the effort required to accomplish all the activities or task in the process model has been decomposed into a few elements. So from there, we have to come out, let's say in planning, in risk analysis, in engineering, we put what is the estimated effort for each of these tasks. Okay, and in the end we come out with some value. So in this case, the total estimated project cost is, okay, here we get 46 multiplied by the historical data, we get 8,000 per month. So the project cost is 368,000, and the estimated effort is, we have already calculated the value, which is in this case is 46. Okay, other than these estimation techniques, we also have automated estimation tools which help the planner to estimate cost and effort. We can also estimate use cases, okay, by having historical data as well. We can try to calculate the cost per line of code, total estimated project cost, and the estimated effort. And finally, the empirical estimation model. So this one is using formulas to calculate the estimated values. One example is using COCOMO, and we can also use the software equation. Okay, and another example is estimation for object-oriented projects. And we can also estimate for agile projects where we can do estimation based on the decomposition of the tasks. And finally, whether the make buy decision, whether we want to build from scratch or we want to buy, it depends on the what is the cost